Alright guys, Coach Goo back at it once again with another fun-filled, action-packed, flipped geometry classroom video. Alright, so today we're going to be going over side, angle, side. Remember, these are different ways to prove that two different triangles are actually congruent. First we had side, side, side. If all three sides are congruent to the other three sides of the other triangle, then those triangles are in fact the same thing. They're congruent triangles, and today we're going to see we can also prove that two triangles are congruent using side, angle, side. So let's read along. If two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So let's take a look at our example diagram right here. I'm going to open the screen sketch. So we've got triangle ABC and triangle DEF. So if, look in this example, we need a side, an angle, and a side. So if AB is, what was that noise? AB is congruent to DE, and now we need an angle. Angle B is congruent to angle E, and side BC is congruent to side EF. You see, look, I've used AB is congruent to DE. The angle B is congruent to the angle E, and side BC is congruent to side EF. Then my friends, triangle ABC is congruent to triangle DEF. And check it out right here. Included means the angle between the sides. Check out how angle B is included. It's between AB and BC. Angle E is included. It's between DE and EF. Alright, so there it is. That is an example of side, angle, side at work. So now we're gonna do some proofs to show you how it's gonna be in action. So some sample SAS, side, angle, side, SAS proofs. So number 4 right here, let's take a look. Follow along. So here we go. I'm gonna use a different color today for funsies. Let's use the maroon one. Alright, so let's see what's given. JM is congruent to NL, so let's label that. JN is congruent to JM is congruent to NL, and then they tell us that angle JMN, that's right here, is congruent to angle LNM, that's right here. So let's do this one. This one looks like it's going to be a straightforward one, so let's take a look. Starting with JM is congruent to NL in step 1. How do I know that? That's in the given. Step 2, angle JMN is congruent to angle LNM. How do I know that? That's in the given. Step 3, now check this out. I already see that I have a side that's congruent and an angle. Now I need one more side, and what side can I use? They didn't tell me that JN is congruent to ML, so I can't use that. But look, this side right here, MN, is used in both the triangles, so MN must be congruent to itself. And this is the first time you're actually going to see that we have to use the reflexive property. Remember, the reflexive, not reflective, reflexive property is where the same thing equals itself. You see, we've proved that JM is congruent to NL. They gave that to us. The angle JMN is congruent to the angle LNM. They gave that to us. Now we need to show that this third side is actually congruent between both triangles. And of course it's congruent to itself, and that's because of the reflexive property. Now, look at the last step. They say triangle JMN is congruent to triangle LNM. How do I know that? Look, I have a side, an angle, and a side, and that is the SAS. And that's the end of this one. Look at that. Let's go to the next one now, and the last one. So let's take a look at the givens here. So AB is congruent to BC. Let's label it. AB is congruent. Whoa, no. We're going to the screen sketch. AB is congruent to BC, and BD bisects angle ABC. What does bisects mean? Bisect, that means that, look at this, BD is cutting the angle ABC directly in half. That means ABD, that means that angle ABD is going to be congruent to angle CB. Oh, I missed my angle. Angle CBD. That's what bisects means. So we might be using that. Spoiler alert. All right, so look at step 1. AB is congruent to BC. How do we know that? That's in the given. Next one. BD bisects ABC. That's in the given. And number 3, angle ABD. Let's look at the picture. ABD, that's right here, is congruent to angle CBD. That's right here. And how did I know that? Look, wow, look at, I already wrote that. That's crazy. How did I know that? Because that is the definition of bisects. Bisects means that it cuts it directly in half. So of course these two will have to be congruent to each other because that's the definition of bisect. Oh, I wrote bisects. Delete. All right, next, BD, that's right here, this line right here. Let me get a more bright color. BD, right there, is congruent to itself. How do I know that? That is the reflexive property. Good job. Yes, I know everyone who's watching this video said that immediately. Yep. Reflexive property. And last, triangle ABD. That's what we're trying to prove. Triangle ABD is congruent to triangle CBD. And how do we know? Look, we've got one side, AB and BC. We've got an angle, ABD and CBD. And then we've got this third side, BD is congruent to itself. So once again, we have finished the proof with SAS. All right, guys, that's these two examples. If you didn't get, if it was a little fast, you know, you can always rewind. That's the beauty of of modern day technology, the ability to rewind whenever you want. And that's going to be the end of this video, guys. So make sure you know side, 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 side angle, side, and I will see you, or you will hear me in the next one. Peace.